welcome to our program, Astronomy for Everyone. With us in studio today is our special guest, Mr. Ken Burton from the Warren Astronomical Society. Ken, welcome back to the show. I know you were here a few years ago.
Yes, I was. Yes.
And our topic for this month is Edmund Hawley, which is actually my first question because, Ken, I've heard several different pronunciations of his name. Which one's right?
Well, you know, one of the biggest problems that's happened through time is Bill Haley and the comets a number of years ago, and everybody wants to call it Halley's Comet. Well, in fact, it is spelled Halley, and it was his family in England now says, the people that have passed, descendants have said that it was Halley. However, there were a number of times he was written letters for the early times of when he was becoming famous, where they actually spelled it wrong as Hawley. So it might have been Hawley. So that was the story of him.
Very interesting. So speaking of his early days, what about those times for Mr. Hawley?
I'm going to just refer to some of my notes as we're going along through it.
Sure.
He had a very, very complex and interesting life. He may have well been the most important astronomer of the 1600s, including Newton. I mean, he was an individual that seemed to be very diplomatic and could get people to do what he wanted by just simply being kind and nice. So I always tell people that's my favorite astronomer of all time. His birthplace was Haggerston, just outside of London. His father was a soap and mining manufacturer, soap and salt.
Okay.
And of course, salt was a big thing because they pickled the
preserved
food with salt.
In the days
and that was a very, very big thing in that. And there was a house in London, but his father, Edmund Sr., by the way, was Edmond, not Und, which you might think. And he had a house in London and also in Haggerston, which was really like a suburb. And probably that saved his family's life because the plague arrived in 1665 and lasted for a year, and people were dying in the streets. They had no idea that rats actually caused the issues with the sanitation, but people that were outside of the city really weren't exposed to as much. So his family survived because of that. And then the next really significant thing that happened in his life was the Great Fire of London in 1666, which pretty much burned the entire town or city at the time. Most of the buildings were destroyed. They had wooden timbers and thatch roofs. And Edmund's father was a builder as well, and he just thrived on that, made a fortune in rebuilding London, which he did in a few years, to the point where he was able to give a stipend to his son of about $300,000 to $400,000 in today's money per year.
That's quite an allowance.
Quite significant.
Yes.
And he was able to do pretty much he did. Now, one of the other significant events during his early life was the death of his mother in 1672. There's no record of what finally did her in, but she did die at that. And of course, you could die of almost anything at the time.
That's true.
With his father John, his brother really got him involved in learning the rules of the world, if it were. And he was a very, very bright young man, and was sent to for his formal education. He was taught to read mostly and write and do mathematics at home. And then he was sent to St. Paul's, where he studied Latin, Greek, and Hebrew, and also had lessons in mathematics and navigation, geometry, and the like, trigonometry, algebra, and astronomy. By 1672, he was enrolled at Queen's College in Oxford, and one of his professors, Anthony Wood, said that he was extraordinary in his advancement in the place of mathematics and trigonometry and navigation, along with all the classical learnings of all the languages. He probably spoke 7 or 8 languages. Very, very smart young man. And that was pretty much what happened, but sparked his interest right there in comets. And in the comets, he was more interested in their schedule than he was in the makeup of the comets. Because at that time, people thought that comets were a harbinger of catastrophe. They said that Julius Caesar died because there was a comet in the sky or whatever.
Even the Bordeaux Tapestry showing the invasion of William the Conqueror has a comet stitched into that tapestry.
That's exactly right. Yes,
Symbols
sir.
of doom.
Yes, but he said that that's not the case. They are probably planetary bodies. You know, Galileo was the first to say that they were not just in the atmosphere. So, the next significant thing that really occurred in England at that time was the building of the Greenwich Observatory in 1675. King Charles II was the one who actually commissioned it. It was built by Christopher Wren and Robert Hooke.
Two very famous English.
Yes, very, very famous. Christopher Wren was probably of the tune of what Halley was, a very, very diplomatic guy who was able to get people to do what he wanted to do.
And this was an engraving of that observatory?
That's correct. That is what it was, and it's still operating today. As a matter of fact, Greenwich Mean Time is that observatory right there, universal time now, of course.
Was it originally built to be an astronomical?
No, actually not. Astronomy was kind of a sidelight for it. And what happened was, concurrent around the time, is the king had appointed John Flamsteed as the first astronomer royal. Halley was the second, but the first one was John Flamsteed. He held the post for a very long time, but what his main thing was navigation. You know, the world was now starting to spread out. And the ships needed to have charts, and they needed to have all the things that go with traveling throughout the world. And it was now a very, very big thing, you know, that Columbus sailed in 1492, and Magellan was up around 1590s, but now it was really starting to become a trade thing. And where countries got a lot of their finances was, in fact, through trade, so they had to be able to be good at that.
Accurate to know where they were to get where they needed.
Right. Now, you had another issue with it. Latitude is easy, but longitude is not. So they were still a few years away from having a clock that could keep you on key as longitude. But they also had another problem, and the other problem was the magnetic variance between polar north and magnetic north.
Ah, yes.
And that comes to the next part of our discussion about him. He was the first to really put that together, and we'll talk about that a little bit later on. But
anything else about his young life?
Well, again, his first thing that he wanted to do was he was the type of individual that was constantly creating things in his mind about what he observed. He looked at his eclipses early and such, but he wanted to get himself involved with astronomy. And here he is like an undergraduate, and he writes this lovely letter to John Flamsteed, blowing smoke up his, to tell him how wonderful he was, you know, and all the things. And he wanted him to take a look at some of his works and some of his thoughts about the setup of the stars. The charts were all created by Ptolemy, and he wanted to start really putting things together so that people knew where everything was, because over the years from the time of Ptolemy, they had moved a bit.
Yes, they had.
And so he wanted to make sure that was done, but he not only wanted to do that, but he wanted to show his calculations. The positions of the planets Jupiter and Saturn were inaccurate on the manuals that we're doing, and that wasn't helping things at all, and he wanted to do that. So he wanted Flamsteed to confirm his discoveries. And Flamsteed was just taken with the kid. He just thought that this kid was wonderful. He brought him in, and he got him involved with the astronomy instruments and such, and really set him on his way toward being a great astronomer. Navigation, of course, was now widespread, but again, the star charts were not right, and also the star charts were not right in the southern hemisphere, particularly not right. So he took a trip on a ship called the Unity down to St. Helena, and he worked there with his with a 30-foot telescope. You can see St. Helena there, and you probably see the Unity ship. That's a frigate. That's not the Unity. That's a frigate of the time. And he went to St. Helena, and he took with him two things that he really needed. And the first thing he needed was a telescope.
Okay.
And he had a 30-foot telescope that he put up, and at that time they had chromatic aberration, so they hadn't figured that out yet. It's going to take another few years to do that. So these refractors were on these long strings out to see the actual objects. Very, very cumbersome. Hevelius had one that was 150 feet that didn't work very well.
Now, he did several of these trips, though, didn't he?
Oh, absolutely. But I wanted to just tell you that two other points that he had was a sextant, which was really a nice thing,
Okay.
but he also had a pendulum clock. And he needed the pendulum clock so he could keep accurate time close to what it was in Europe. And not only that, he figured out that because he was on a mountaintop, that he needed to shorten the pendulum in order to get it at the right time. It was very, very interesting.
Sounds like we have some interesting things to cover in the second part of our program. We're going to take a quick break, but before we go to Term of the Month with Stephen Witte, I do want to mention that our old website is no longer operative. And so for the time being, we would like to direct you over to our club website, FordAstronomyClub.com, to get the latest information about not only the club, but our show as well. And right after Term of the Month with Stephen Witte, Ken Burton and I will be back with more of this discussion of Edmund Halley.
Thanks, Don. The term of the month for March 2015 is golden stars. These are not stars that are colored yellow. Researchers in the U.S. and in Germany found a new kind of star. These are stars that are variable stars, and they pulsate in a fractal manner, and they call them strange, non-chaotic attractors. This is math. You don't have to know the math. That's what it is. These researchers used the Kepler spacecraft, which is ideally suited for this sort of investigation. Researchers expect that new stellar physics and/or at least some stellar classification improvements may come out of this research. Now, variable stars brighten and dim, and the Kepler spacecraft has been looking at 100,000 stars to see extrasolar planets that are zipping around, dimming the star a bit. But the Kepler spacecraft has been looking at these stars every 5 minutes. So the researchers used some math and discovered the golden ratio appearing in the periodicity of the brightnesses and dimmings. Now, the golden ratio appears in geometry, and here it's a little complicated. If you look at the size of A and the size of B, the ratio between those two is the same. But it's also the same for the rectangle that's vertical on the right side. It's kind of an interesting thing. Anyway, the ratio is about 1.62. It's an irrational number. Like pi, it goes on forever, doesn't repeat, and so on. The RRC Lyra variable stars that they found that had this turn out to have a large number of frequencies. So they pulsate at a large number of different frequencies, but they are related to two fundamental frequencies. And in this case, they happen to be, these fundamental frequencies have this golden ratio. One is slightly higher than the other. In the strange non-chaotic attractors thing, strange means that it's fractal, which means that you have big patterns and little patterns that are like the big patterns. And non-chaotic means that it's somewhere in between chaos and order. Now, order would be something that happens exactly periodically, like Old Faithful, for example, the geyser in Yellowstone. This is considered to be the first dynamic system of the sort, this non-chaotic, this strange non-chaotic attractor that has been ever discovered in nature. Now, the peaks are constant but as the stars pulsate, they get brighter and brighter up to a threshold, and then it drops completely, and then it displays this power law. And this same power law, this same exponent of the power law, appears if you do the same sorts of math on the coast of a map of Norway. It's a peculiar coincidence. In any case, we expect that further research will do all sorts of nifty things. Golden Stars is the term of the month for March 2015.
Thanks, Stephen, and welcome back to our show. We're talking with Ken Burton, a member of the Warren Astronomical Society, who is here to tell us all about Edmund Halley. Now, we were talking a little earlier about his younger life, but most folks know him best by the comet.
And actually, the interesting thing about that, Don, is the comet was probably one of the least important things that he did. He was able to, for the first time, figure out that comets have a period. That's what it is, from time to time. And of course, the one great comet that he saw was eventually named for him, Halley's Comet. What he was having trouble with was with the orbits of both the planets and the comets. And the interesting thing that goes with that is that's when he started to deal with Isaac Newton. Isaac Newton was a reclusive, brilliant man who had written a book in the 1660s, 1665 or so, and didn't publish it because he didn't want it for whatever reason. He was a little bit of a crackpot. But Halley befriended him, which was hard to do. And he became a close friend of his. He went to Cambridge to speak with him. He wanted to figure out how Kepler's third law applied. That was the more difficult one. And it actually detailed the fact of ellipses. And as soon as Newton saw what he was trying to do, and that's Kepler on your left and Newton on your right, he said, well, it's ellipses. And he said that makes sense. And what he did is he applied then this new thing that he had discovered called calculus. They called it fluxions, as a matter of fact, that was the name of it. But he actually applied it to the measurements, which made all of the measurements for the computations by Halley work. And of course, Halley caught right onto it. And that was an important aspect. Now, just to follow Newton's thought for another second, he finally convinced Newton to publish Principia Mathematica, Philosophiae Naturalis Principia Mathematica, better known as Principia, which dealt with gravity. That's the apple and the tree and all that other stuff that goes with that. But the fact is that the most important thing was this aspect. That was me. That's okay. Yes, it was. He was able to figure out the orbits and was able to do the things for Jupiter and Saturn. All this he was able to do because of his relationship. Newton still didn't want to publish. So what happened was Halley said, look, he says, I'll tell you what, you publish it, you give me the manuscripts, and I will publish it. And Halley paid for the publication of Principia. And the rest is history as far as physics is concerned, and didn't change at all until Einstein. So there you are.
So it was Halley's friendship with Newton and Halley's money that made this publishing happen.
Going with that thought, Robert Hooke had come up and said, I discovered that before you did. And he said, well, why didn't you write anything about it? He says, I never did it. He said, Newton is the guy that did it. He says, and then Newton got mad at Hooke and said, I'm not publishing any more, because there's 3 volumes to Principia. He wasn't going to publish the last one. And Christopher Wren jumped in at that point in time and said to Hooke, back off. And that's what pretty much did it. And then he did publish the last of them, and that was really the cornerstone of that.
So then at a certain point, then John Flamsteed gives up or dies in the office of Astronomer Royal.
Well, more to that set with Flamsteed was Flamsteed didn't like the popularity of Halley.
Even though he liked Halley at first, thought he was a great young man.
And he sent him down to dismember this Hevelius stuff, and said that it was out of the line. He said he never worked with him again. He didn't like Newton at all, but that wasn't hard to believe. But that was it. And what happened was the other aspect of Halley that we should just touch on is he was a member of the Royal Society, and his father died. And then he wasn't getting his big income, so he wanted to become the secretary of the Royal Society. Couldn't do that as a member because you were nobility and you couldn't get paid. He needed to get paid, and so he dropped out of the society and then became the secretary, and everything scientific crossed across his desk. He was so good that if two people came in with the same idea, he would say, let's both of you put your name on it. Or he would negotiate. Or if one came in, even if he figured out something, he would give the credit to them. And that was the type of individual that he was. And then, as Flamsteed later on blocked Newton, he blocked Halley from publication of certain things. The fact of the matter is that they said that Flamsteed was a jerk, and we're not going to deal with him anymore, and discredit him. And then finally Flamsteed died, and Halley was appointed Astronomer Royal. And that's pretty much in a nutshell what went on. There's a lot of other things to it, but
A lot of details.
a lot of details.
But again, it sounds like Halley was one who could work with people, very personable, work with somebody like Newton and Flamsteed.
He also was, the Royals also sent him to negotiate with the Russians. He negotiated with the French. He negotiated with all these other companies. And
So he was doing things in politics as well as science.
Yeah.
And wasn't he involved with the Mint as well?
yes, he did. He was a member. He did work with Newton on the Mint. And the last item I want to discuss is one of the greatest contributions, and I think you said we have about a few more minutes left. That's great. He got a ship called the Paramore. Paramore was this pink, very, very, very unstable ship. There's a photo of it. It had a lot of, he could take a lot of equipment. Okay. And he sailed away on the Pink, and for his first voyage of 3, and went down to St. Helena and turned around because he had a guy named Harrison that was on his book, that was a second mate that was appointed to him, that he had rejected with the society. And he had an axe to grind, and he tried to produce a mutiny, and Halley went back. And he was put on trial and such, the Harrison. Then he goes down, again, his second trip, goes almost to South America, and then he develops the most important thing, is the difference between magnetic variation of the polar magnetic, and magnetic, polar.
The true polar and the magnetic.
And he was able to do that. He was also an expert in tides. And his last journey was down the coast of France because they were at war. He was in a secret mission to spy on the French, and never said anything about it in any of his publications or anything, but that's what he was doing, and also measuring tides at the same time. And that was basically...
He sounds like a fascinating fellow, and a lot more to him than obviously just the comet. I want to thank Ken Burton from the Warren Astronomical Society for being our guest and giving us this fascinating story about a truly fascinating man. If you have any questions, please send us an email. The email address, which does work, unlike the web address. You can see the address down there at the bottom of your screen. And coming up next with What's Up in the Night Sky is our own Stephen Whitty. Thanks for watching.
Thanks, Don. Now for What's Up in the Night Sky for March 2015. The sunrise at the beginning of the month is 7:09 a.m. and at the end of the month 7:18 a.m., just a little later. Sunset at the beginning of the month is 6:23 p.m. and at the end of the month it's 7:57 p.m. So also a little bit later the days are getting longer in general. Your times locally are going to be a little different because this is for Southeast Michigan. The moons, the month starts with a full moon on the 5th of March. Third quarter is on the 13th. The new moon, which you probably won't see, is on the 20th, great for looking at deep sky objects. And the first quarter is on the 27th. Venus sets starting at the month at 8:50, and by the end of the month, it's 11 o'clock. So Venus is getting farther and farther from the sun, getting higher and higher in the sky. So the ellipse there you see, that's Venus's, it arcs, that's the path of Venus. It arcs higher and then goes lower. So it's still going higher. Below Venus there is Mars. It sets at 8:32, so a little earlier, a little closer to sunset. And by the end of the month, 9:31. So it's also it's not getting farther away from the sun, but it's pulling ahead as it goes around the Earth. Uranus is very, very close to Mars. It sets at the beginning of the month at 9:07 p.m., but we have superior conjunction. You will not be able to see it by April 6th. That's not far from now. But right here at the beginning of the month, it's 2 degrees from Mars. So Mars is a good way to spot Uranus if you've got a telescope. You should also have a sky chart. Jupiter sets at 6:13 in the morning at the beginning of the month and 5 o'clock at the end of the month. Jupiter was just at opposition, so it's basically up all night. We're just starting to see it rise in the morning. Saturn rises at 1:23 in the month, and by the end of the month, just a little after midnight, 12:24 a.m. So Saturn is really kind of a morning object. That's just how it is. Neptune had superior conjunction just recently on February 25th, so you're not going to be able to see that. And we still have Comet Lovejoy. And this month it's near Cassiopeia, or Cassiopeia, depending on how you want to pronounce it. And we've got the finer chart here, but we also you should also look at skymaps.com to see where Cassiopeia is. Binoculars ought to be able to get you a good sight of this comet. So that's what's up for March 2015. And so get out there and look up in the sky. It's the greatest free show there for you every night.